Good afternoon to everybody. I'm Anibe Onuche from Internet Exchange Point of Nigeria. I want to start by giving a brief history about what led to our implementation of AS-PAT transparency using BIRD. We were having issues on our networks, packet drops and all sorts of things, but there was a particular incident. A customer came and said he's receiving inbound traffic, but he's not getting the outbound traffic. And he asked us, where did his traffic go? We said, we don't know. Maybe he should check it on his own side. But he provided a solution. We came to a conclusion that we should be able to, we should do a direct private peering, a bilateral peering with the customer he wants to have a traffic with, and it solved the problem. Later on, we started getting more complaints from our customers that they too want to have the private. Okay, they wanted to have a better private pairing. A private pairing or bilateral pairing with the customer, and we thought of it that let's find a common solution to the problem. And what came readily to mind was the AS-PAT transparency. Now the agenda is just very quick. I'll be quick about it. What is AS-PAT transparency? Why BIRD, topology and scenario, and the benefit of AS-PAT transparency. What is AS-PAT transparency? AS-PAT transparency occurs when the AS-PAT is invisible, not included, suppressed in the update between two eBGP pairs, and is in a server-client relationship. A route server, and how do we achieve it is through implementing a route server. A route server does not insert its own AS number in the AS-PAT update to the client, thus providing AS-PAT transparency. The other things included, maybe like Andy just explained, that you can adjust the MED to your own configuration and the next hop possibly. When a route server client receives an update from a route server, the server AS-PAT MED and next hop are transparent, not included in the update. For Cisco, the extra configuration has to be added. That's on the client side, no BGP enforce first AS. Peering appears to be between the two neighbors, but in reality, the route server mediates this peering. This is invisible to the peer concerned. What I mean is that there's a route server in between two pairs. So the route server, when various clients connect to it, it appears transparent. Its AS-PAT is not there. The next hop, the client does not see the route server as the next hop, rather the destination part as its next hop. So let's go on. In a non-route server setup, we have this scenario where you have ASN 10, ASN 50, ASN 20. Our route server here is ASN 50. What happens? You can see it goes through the path, and the packet that left ASN 10 goes through the route server, the server setup. But in this scenario we are generating, the route server is not transparent. So I said in a non-route server setup, the packet leaves ASN 10 to ASN 50. You can see that the AS-PAT, when it gets to ASN 20, is 10, 15. The AS-PAT is 10 and 50. I'm just using a small scenario. Now, in a route server setup, this is what happens. The packet leaves. You can see from the graph, the route server becomes so transparent. it appears as if it's not existing. It's so transparent. So the packet leaves ASN 10, goes through an invisible route server and arrives at the other pair. And what do we have? The ASN part is just 10. Compare it to the former one. The former one was ASN 50 that was included in the ASN part. But you can see the route server is transparent. It's there, but it just doesn't involve itself in the routing. So it leaves ASN 10, goes to arrives at the other pair as ASN with only ASN part 10. Next slide. Okay. Why bird? Why bird? Why not Cisco? Why not Quagga? Why not everything? The first thing is it worked for us. Simple, it simply worked for us with minimal hassle. We had issues with other vendors. Why? Because their implementation was so pricey, and we couldn't afford it. And also the implementation was with a lot of configuration. We had a case of a particular ISO image that didn't scale up. When it got to 100 or 50 pairs, it took a longer time to propagate the route. But BED does not have that issue, and also it was very quick for us to implement. It has all the fully functional dynamic IP routing demos. We have OSPF, RIP, and a host of others. And it's open source. That's good news for African internet exchanges. It's open source, software based, and that means or like how does it affect us? We can buy servers with minimal hardware, and it will run perfectly as we wanted it to be. Now I'm going ahead to configure some scenario. You can see that we have IXPB, we have both are connected to the two IXPs. Both are connected to the two IXP, and unfortunately, in this scenario, IXPB also has a connection to IXPA. IXPB through a less expensive route to reach to ISPA. Okay, we have this. You can see the various routes that some of the packets are passing from ISPA to IXPB to IXPA down to ISPB. So many paths that are taken, and this is really not. This looks like a poorly configured network. So, like I just explained earlier, ISPA is connected to both IXPA and IXPB. The same goes for ISPB. There's a path that exists between ISPA and ISPB. ISPA is the upstream provider for both ISPA and ISPB. IXPA connects to so many nomenclature. I hope you go through it when you download the slides. Now, benefit. One of the benefits of using the bird is traffic increase within your network. Why? Because you are the preferred path. When you implement a route server implementation and you achieve AS path transparency, there is will be in most scenarios, you will be the most. I have a packet leaving ISP-A, going through ISP-B. I have another packet again going back. I have another one going through ISP-A, and I have another going back, and also the last one going, all of them different paths from ISP-A to ISP-B. The challenge is we want all the attention. The ISP-B is our main focus. We want all the attention, we want all the traffic, we want everything to pass parts to see the various part from ISP, just a confusion. And one of the things that you will note, there is a significant traffic is not accounted for. Significant traffic is not accounted for. You might be asking, why is IXPA sending traffic to ISP-B? Maybe it sees it at a less expensive route and wants to take advantage of that. What happens? The traffic goes between all the traffic that was intended for ISP-A goes through the lesser AS part. Remember I said when a route server is when you have a RS implementation, that's the route server implementation, your route server does not include the AS part, so it's like one AS pass less. So chances are that you will be the route server will be a better part, will be a much more better part to achieve this. Among all the parts, is very probable, is very likely that the link, the most preferred part, instead of all those merry-go-around, it will be within the route server part. And what we have here is that the packet leaves ISP-A and goes through IXP-B, which is transparent, and goes to ISP-B, and also the traffic returns through the same route. There's no other way, because after better traffic as part is likely to be preferred. And I'll say this is good traffic engineering. Another benefit is we had this issue asymmetric routing. Now let me explain what asymmetric routing is. It can be affected with asymmetric routing. The path taken inbound, the path taken by packet outbound might not be the same with the packet inbound, and when they don't arrive at the same sequence and at the same time, there is bound to be packet loss, and possibly your traffic might be even be slower because of the retries, so it's slow. But when we achieve the RS implementation, the AS part, the MED and the next hop is optimized, that is transparent. Best part is most likely to be the route server part. And even when we return it, it's more likely that the packet will return through the route server part. It's more probable. And this next hop also, the client, the route server client does not see the route server as the next hop. It sees the destination network as the next hop. So update from originating pair gets to the intending destination pair scenario, and it has less hop. And just a recap of the benefits. There's more traffic generated. The part where the route server is possibly and most likely going to be selected as the best part. It's going to be more likely to be selected. The chances of being the less part is very, very high. And also it prevents asymmetric packet loss, and also there's a less hop. What I mean is that when the AS part is not there and the next hop is not there, you have obstacle to achieve your aim. Any question? Sorry, I have to be because of question.
I have one for you, Anibe. Okay. So since you implemented BAD, have you had any response or comments from your members at the IXP, the members connected to the exchange point?
Right. In answer to that, most of the complaint dropped because we saw a lot of asymmetric routing in our network, but when we implemented it, those complaints never came back. But per week we were receiving complaints that there was a problem with, there was a lot of asymmetric routing. People said they couldn't, like the customer that I explained to you in the first instance, he said he didn't see any inbound traffic into his network. He didn't see any inbound, but after the BAD implementation, we saw inbound traffic coming into various networks, and also we saw some traffic increase on our own side. So at least it rose up to close to 200 meg, and simply put, the complaints were reduced to the barest minimum. Any other question? I would like to make a comment here, and I was planning to put a workshop, maybe a slide on good expert. Andy, please, Andy, where's Andy? Okay, Andy is just there. He's a bird expert. Please, Andy, come. Andy was the one that encouraged me to implement BAD. Please come on the podium, please. So you will, anytime you see him, you can say about BAD implementation. Please, can you say BAD?
Oh, of course. Let me think back to around 2008 or 9. We tested Quagga, BAD and OpenBGPD in part of a lab along with friends from the Amsterdam Internet Exchange, London Internet Exchange, the Internet Exchange in Warsaw. A few of us got together in one room in London, and we really stressed the performance of BAD, OpenBGPD and Quagga, and we found that BAD was the most reliable with a large number of peers and a large number of routes. They all perform relatively the same way when you have a small number of peers and a small number of routes, but BAD was the most stable and the most reliable under pressure. It has the most extensible filtering language, and it's also the most memory efficient when you run multiple routing tables. So if you run one routing table on your route server for each peer, so that they can use communities to filter between them, BAD was able to deal with the more complex results of having multiple routing tables. So at LONAP we used BAD and OpenBGPD for a long time. We just had to turn off our OpenBGPD server, replace it with another BAD server, because OpenBGPD couldn't cope with the 150 peers and 40,000 routes in the way that we wanted it to. So we just have BAD servers now, but I'd still like to see a second root server daemon that can stand a relatively medium-sized exchange. Okay. That's what I think. So the reason that we use commodity hardware and open source daemons is because the features that we need often aren't in the BGP daemons that you can buy on off-the-shelf routers. So it wasn't an option for us to Okay, so because we're in London, we buy in pounds sterling, but we were able to run I think about £500 bought us a server with reliable hardware, 8 gigs of RAM, fast enough disk to boot quickly and all this. 8 gigs of RAM is what you need for a medium-sized exchange. Large exchanges need much more. Smaller exchanges probably need less. Bird itself isn't a big CPU challenging task, but if you buy current generation or 1 generation old technology, as long as you have enough RAM for the number of routing tables that you have, Bird is quite reliable, and we were able to do this on like a cheap mid to entry level Dell or something we use. It just works.
Okay, my last comment is please, Bird is becoming like a global standard practice. I'm encouraging all the IXPs in Africa. I mean, it's going to be a wonderful experience. You can contact me or mostly contact him to implement Bird. And we are more ready to help, and I'm employing Afrinic to implement those Bird servers. I mean, we are going to have, I'm trying to push forward on an advanced BGP routing in our AFNOC program that we should include Bird in our syllabus, and I hope Andy too will be of much help. Thank you very much. Thanks for listening to me.
If I didn't know better, I would have thought the bad folks are paying Anibe for the marketing, but thanks very much. Okay, so thanks again for the two presenters. I think that was very useful to sort of get both presentation on how to, the things that you need to do to optimize your network and the benefits of BAD. We are just about into lunch, so before we go for lunch, we have our first session of peering introductions for those who've sent in your slides. So I'm going to play them. I'll call out the names. Please come to the mic and make the introduction. If you know you've sent me an email, I already have your name up, so please come up to the mic and we'll do the introductions now. So we have Afrinic, Akamai, Jaguar Networks, DNS Services, Cloudflare, Telcom Egypt, Mosix, Liquid, NetNode, KXP, AfriConnect. So to the mic.